Hello, everyone. Welcome back to our channel. Today, we will revise chapter 3 of chemistry. That is related to the bonding. Okay, so we will revise all the past paper questions from 2016 to 2024. So let's start. Question 1. Which molecules contains a double covalent bond between two atoms of the same element? So now they are asking about the covalent bond. We already know that covalent bond is actually about sharing of the electrons, right? So all of them are sharing the electrons, but we have to see that which one contains a double bond. Carbon dioxide, sorry, ethanol, ethene, nitrogen. So ethene is the right answer. Why? Because they are saying carbon dioxide also contain double bond, but in ethene we have C2H4, right? So the double bond is between carbon and carbon, and they are asking that two atoms of the same element. So same element is here, carbon and carbon. That's why the C option is correct. In carbon dioxide, the double bond is between carbon and oxygen, not between carbon and carbon. Okay, so that's why option C is correct. Question number 2, which statement about nitrogen molecules and ethene molecule is correct? Option D is correct. Why option D is correct? If you see the nitrogen molecules, a nitrogen molecule has two more shared electrons than an ethene molecule. No, if you see, nitrogen has only two molecules, right? So each of them will share 3 electrons, because in nitrogen we have a triple bond. So the total shared electrons are 6, right? But in ethene, C2H4, we have total 12 electrons that are shared. So the option D is correct, because ethene molecule has 6 more shared electrons than the nitrogen molecule. Which statement about methane is correct? In methane, positive hydrogen ions are attracted to a negative carbon ions. In methane, okay, so now methane is made up of carbon and hydrogen, right? CH4. So carbon is a non-metal, and hydrogen is also a non-metal. And covalent bond is always formed between two or more non-metals, right? So why they are saying that positive hydrogen ions, it means there should be no ions in the covalent bond. Covalent bond is about the sharing of the electrons, right? And in covalent bond is formed between non-metals. So methane is made up of two non-metals. So this option is wrong. Option B, in methane, electrons are shared between carbon atoms and hydrogen atoms. Yes, that's right. Because in methane, they both are non-metals. So non-metals always make covalent bond, right? So covalent bond is what? Is the sharing of the electrons. So option B is correct. And covalent bonds, always the compounds that are simple covalent compounds, they always have a low boiling point and they are very bad conductor of electricity. So that's why C and D option is also not right. Question 4, which diagram shows the covalent bonding in a molecule of carbon dioxide? It's simple, carbon, because it belongs to group 4, so it needs 4 electrons in its outermost shell. What does it mean? It means it will make 4 bonds. So can you see where it is making 4 bonds? Yes, here in option C. 2 bonds with one oxygen and 2 bonds with the other oxygen. So total 4 bonds it is making. So option C is correct. Let's see question 5. In which molecule are all the outer shell electrons in covalent bonding? So when they are asking about that all the electrons are involved in covalent bonding, first you have to remember that I am just giving you a trick. You have to see if there is any compound that has hydrogen in it. Because usually, whenever hydrogen make a covalent bond, it has only one electron in its shell, right? So of course that will be used for covalent bonding. So you have to find the first one that has hydrogen in it. So if you see A is rejected, B, C, or D can be the right option. Now, the second hint I will give you is that if you see carbon, any carbon atom, the group 4, they are always, when they are making a covalent bond, they will use to share all these 4 electrons, because they need 4 electrons to become 8, right? 8 is the stable configuration. So carbon has 4 electrons in its outer shell. So usually carbon is the one that always try to use all its 4 to make it 8, right? So whenever you see carbon and hydrogen together, that will be the best option. So where we can see carbon and hydrogen together? Yes, here. So the option B is right. A covalent molecule Q contains only 6 shared electrons. What is Q? So a covalent molecule Q, so now it's again a covalent molecule, right? So it is sharing 6 electrons. So now we have to see here where we are sharing the 6 electrons. So if you see for ammonia, ammonia is making 3 bonds with the hydrogen, right? So ammonia is sharing 3 electrons and hydrogen is also there are 3, so they are sharing 3 electrons. So I think A option is right. So we already see the first option, because if you see the molecules in covalent, for example, I will give you a hint over here. Whenever you see a covalent compound, okay, and there is no double bond. So if there is no double bond and it is a covalent compound, then the sharing will always, you have to exclude one number from the total number of the atoms. So if you see here, how many atoms we have? Nitrogen 1, hydrogen 3. So total, how many atoms we have here now? 4, right? So when we have 4 atoms here, so it means total 3 bonds will be present here, right? So when 3 bonds are present, so if they are sharing the electrons, so each bond is sharing 2 electrons. So 3 twos are 6. I hope you got this point. Like for example, here you are seeing 2, right? There are 2 chlorine molecules. So it means it is only sharing 1 bond, right? And 1 bond means 2 electrons are shared. So in chlorine, we are sharing only 2 electrons. In methane, if you see here, this is also 3, right? In CH4, if you see, carbon is making 4 and 1, 5. So 5 minus 1 is 4. Actually, we are making 4 bonds. So 4 bonds are sharing 8 electrons. So I hope you get this point. But this trick is only for those covalent compounds in which there is no double bond. Remember that, no double bond. And then you have to just count the number of the atoms present. For example, if it is 5, you have to think, okay, 4 bonds are present. If the atoms are 5, then the bonds will be 1 less. So 4 bonds present means that 8 electrons are shared, okay? Because each bond is sharing 2 electrons. Question number 7, how many electrons are used to form covalent bond in a molecule of methanol? So now let's see methanol. This one also don't have any what? Any double bond. So now let's count how many atoms we have here. 1, 2, 3, 4, 5, 6, 7. So total we have 7 right here. CH3OH. 3, 4, 5, sorry, 6. We have total 6. So 6 minus 1 is equal to 5. So it means total we have 5 bonds here. So 5 bonds means total how many electrons are shared? 10 electrons are shared. So option D is correct. Question number 8. The table shows the electronic structure of 4 atoms. Which 2 atoms combine to form a covalent compound? So for always to make the covalent compounds, you have to see the electronic configuration should be of non-metals. Okay, so non-metals usually have more than 3 electrons in their last shell. You have to remember metals usually have 1, 2, or 3 electrons in their last shells, but 4 or more than 4 is about the non-metals. So let's see which one has the more than 3 electron in its last shell, X, Y, and Z. If you see X, Y, and Z have the more than 3 electrons in their last shell, right? It has 4, this one has 7, and this one has 8. But 8 is a stable configuration. It means it's a noble gas and we don't need to form any covalent bond. So what we are left with now with X and Y. So where we can find X and Y, it's C, okay? So option C is correct. So remember that covalent compounds are only formed between 2 or more non-metals, only non-metals, right? And I already told you what is the electronic structure of non-metals. It is actually, they have large shell. In their large shell, we have more than 3 electrons. They are actually the non-metals, okay? Question number 9, sulfur is a simple molecule with the formula S8. So sulfur is a non-metal, right? And it is a simple covalent molecule now. So which row describe and explain the melting point of sulfur? So covalent molecules or covalent compounds, if they are simple covalent compounds, they are not the giant structures, then they always have a low melting and boiling point. Remember that. Okay, so it's a simple molecule, so it means it has a low melting point. C and D option is correct. Now we will see the reason behind it. So the reason behind the low melting and boiling point is actually the bonding, right? But covalent bonding, remember that it is a strong bonding. It's not a weak bond. Covalent bond is not a weak bond. The bond actually which is responsible for the low melting point is actually the attractive forces between the molecules. Between the molecules, we have some attractive forces in covalent compounds or in covalent molecules that make them having a low melting or boiling point. Clear? So now let's see this one. The forces of attraction between sulfur atoms are weak. No, because between sulfur atoms we have a covalent bond, right? And covalent bond is not very weak. So the forces of attraction between sulfur molecules are weak. So if you have S8, then there will be another S8, S8, S8. So these S8s, when they are combining together, they have weak intermolecular forces between the molecules that are actually responsible for low melting point. That's why option D is correct, okay? The weak forces of attraction are always between the molecules, not between the atoms. I hope this point is clear. Let's see which dot and cross diagram shows the outer shell electron arrangement in a molecule of nitrogen. I already show you a picture over here. You see nitrogen nitrogen belong to group number 5, right? So 5 means it needs 3 electrons. So its valency is 3. It needs 3 electrons to complete its outermost shell. So 3 electrons means what? It means it will share 3 electrons. So each nitrogen will share 3 electrons, right? You can see here. So we have to find in which the nitrogen is actually sharing 3 electrons, because total are 5. So 2 should be outside. So here we can see in B, it is sharing 3 electrons, right? 3 dot from this end and 3 cross from this end, right? So 6 electrons are shared, and then you can see over here that 2 are also outside. So B. So B option is correct. Let's see question number 11. Which diagram represent the outer shell electron arrangement in nitrogen molecule? It's again the same, but they give you the option here now. So you can see over here that option D is correct. Question number 12, which diagram show the outer shell arrangement in a molecule of carbon dioxide? So now I already have given you the picture of carbon dioxide. This will not be given in the exam, but you can see that because carbon belongs to group number 4. So it needs how many electrons? 4 electrons, right? To complete its outermost shell. So for 4 electrons, it means it has to share now 4 of its electrons also, because it has 4. So it also need to share all those 4 to make to complete its outermost shell. So 2, it will, because we have carbon dioxide and we have only 2 oxygen. So what does it mean? It means it has to share 2 bonds with oxygen and 2 bonds with another oxygen molecule. So if you see over here, the carbon is making double bond with this oxygen also and this one also. So now what we will get over here, we have to find that where the carbon is making 2 bonds. Let's see. Okay. So carbon is making 2 double bonds here, right? Can you see in the A? Yes, it's making here. But here, if you see, it is just making 2 bonds, but there is no electrons from the oxygen. So this one is rejected. If you see here, also rejected, because there should be 4 shared, right? This side, the 4 electrons should be shared, and also here 4. So this one is also rejected. This one is also rejected because 4 electrons are not shared here. 2 electrons are shared here, 2 electrons are shared here. But if you see here, 1, 2, 3, 4, 4 electrons should be shared. So only option A is correct. Clear? Let's see question number 13. Which dot and cross diagram show the outer shell electron arrangement in a molecule of carbon dioxide? Again, we have a different question we have to see again. So 2 cross, we have to see 2 double crosses. Again, that it means that 4 electrons shared here and 4 electrons shared here. So if you see, only in this one, we have 4 electrons that are shared. So option A is correct here. 3, wrong. Here we have 2 here, 2 here. So that's also wrong. Here we have no sharing of the electrons because it's only for the carbon, but oxygen is not sharing. So option A is correct. Question 14. So now in the exam, usually you will see the electronic structure like this, not like this one, because this is from the past papers, but usually now you will see the questions having the structures like this. Okay, so it will be more easier for you. Ammonia NH3 is a covalent molecule. Which diagram show the outer shell electron arrangement in a molecule of ammonia? So if you see nitrogen needs 3 electrons in its, okay, to complete its shell, and hydrogen just need 1. So now we will see where the hydrogen is sharing the electrons. So when hydrogen is sharing the electrons, it has only 1 electron in its outermost shell, right? So when it has 1 electron, of course, it will be sharing that one, right? You can see over here. So now here outside, there will be no electron because there was only 1 electron that is used here. So can you see anyone that has outside there is any electron? In this one, we can see, right? 1 electron is here and 1 is inside. It means this is wrong. It is showing like hydrogen has 2 electrons. That is wrong, right? This one also showing hydrogen has 2 electrons. That is wrong. So only A or C option can be correct. So now let's see which option is right. So nitrogen belongs to group number 5. So it has 5 electron in its outermost shell. But if you see here, they are just showing you 1, 2, 3. And here they are showing 1, 2, 3, and 2 are outside. So it means option C is correct. Nitrogen has 5 electrons. Okay. Question number 15, which diagram does not show the outer shell electrons in the molecule correctly. So let's see now which one is not showing. This is hydrogen. Both hydrogen are sharing the electrons and they are in the center, right? So that's correct because there is no hydrogen, no electron outside. Only there is one electron from each of the hydrogen that has been shared. Okay. Now let's come for HCl. So HCl has how many electrons? A chlorine has 7 electrons. So you can see 1, 2, 3, 4, 5, 6, and the 7th is shared here, and hydrogen is sharing one of it. So that's also right. Now let's see for this one. Carbon has 4 electrons, and all the 4 of them are shared here. Can you see? And also for hydrogen is also sharing all its 1, 1, 1 electrons. So that one is also right. Let's come toward chlorine now. So this chlorine should have 7 electrons, but if you can see over here, it is only showing 1 electron here because this electron is from this chlorine, right? So this chlorine already has 7 electrons, but this chlorine, they are showing 1. So it means option D is wrong. The outer shell electrons are not represented correctly. Question 16. Methanol CH2O has a boiling point of -19. At -20, the liquid methanol is a non-conductor of electricity. Okay, so in a sample of methanol, of course, methanol CH2O, so all of them are what you can see: carbon, non-metal; hydrogen, non-metal; oxygen, non-metal. So it means it is a covalent molecule, right? It's a covalent compound. So covalent compound, how you can get a covalent compound? Which statement describes the bonding between the carbon atoms and oxygen atoms in a methanol? So you see here, carbon and oxygen. Don't think about hydrogen. They are just asking about carbon and oxygen. The carbon atom and the oxygen atom share 4 electrons. Is it right? Yes or no? Why not right? It's not right, I think, because carbon is making 2 bonds. Carbon needs how many electrons in its outermost shell? Of course, 4, because it belongs to group 4, so it needs 4 more electrons. So it will share 4 electrons. 2, it is already sharing with hydrogen, right? So how many are left? Only 2. So actually, carbon is just making 2 bonds, sharing 2 electrons, with oxygen. So if you see, the option B can be right because the carbon atom and the oxygen atom share 2 electrons. Oh, sorry. Oh, the carbon atom and oxygen atom share 4 electrons. Yes, sorry, my mistake. Carbon is sharing, of course, 2 electrons, but 2 electrons are also shared by oxygen. So option A is correct. So total 4. 2 from carbon and 2 from the oxygen. Okay, the carbon atom and oxygen atom share 2 electrons. That's wrong. Why? Because total is 4. Carbon is a negative ion and oxygen is a positive. Of course, that's wrong. It's only for ionic compounds because in ionic compounds, they make the ions. So C and D, both options are wrong because it is about the ionic compounds. And in covalent, we don't have any ions. We are just sharing the electrons. Question number 17. Which statement explain why methane has a lower boiling point than the water? So if you see methane, it is CH4, carbon, hydrogen. Both are non-metals. Water, H2O, both are non-metals. So both have actually the covalent bond. So let's see now why methane has a lower boiling point than the water. Methane has a weaker covalent bond than water. That's wrong. Covalent bonds, I already told you, they are not weak, okay? Methane has weaker attractive forces than the water. Yes, that's right. Weaker attractive forces between the molecules, right? So attractive forces, if you see the word, it means the same like intermolecular forces. So that's why methane has weaker attractive forces than the water. That's why this option is right. The other options don't depend on the boiling point. If something is heavy, it has more bonds or less bond. It doesn't depend on the boiling point. The boiling point always depends, or the melting point depends on the bonding, how strong a bond or how weak a bond is. Okay. Question number 18. Molecules containing only non-metal atoms are covalently bonded. You see, right there now they have told you that molecules that have only non-metals, they will make a covalent bond. So the formula of 4 covalent bonded molecules are shown here. Okay, which of the molecules contain double bonds? Which one of them contain double bonds? So if you see for nitrogen, nitrogen need 3 electrons in its outermost shell. So nitrogen always make a triple bond here. Okay, so this one don't have a double bond. Carbon dioxide, yes, carbon dioxide is making double bond. Each carbon is making double bond with one of the oxygen on both sides. Okay, then ethene, of course, it belongs to the which group? Alkenes group, and alkenes are already famous for having a double bond, right? So alkenes, so ethene and carbon dioxide, they both have a double bond. Methanol, of course not, it doesn't have a double bond. Even if you try to make a structure, you will see that methanol doesn't make a double bond. It's just making a single bond. Carbon is making 3 bonds with hydrogen and then 1 bond with oxygen, and oxygen needs 2 bonds. So one it already make with carbon and the other it will make hydrogen. So all are single bonds, right? So 2 and 3 option is correct. That is B. Question number 19. Which row describes the formation of a single covalent bond in methane? So let's see now. In single covalent bonds, how many electrons are shared? Actually, 2 electrons, right? One bond shared 2 electrons. So let's see that where we can find this one. Atom shares a pair of electrons. A pair means, of course, 2 electrons. So this option is right. B option is also right. Electrons are transferred from one atom to another. That is wrong. They are not transferring the electrons. It's happen only in ionic compounds, right? So only option A or B can be right because covalent bond is sharing of the electrons. So let's see now which option is correct here. A or B. Both atoms gain a noble gas electronic structure. Yes, when they share the electrons, both atoms will gain the noble gas electronic structure. Okay, so that's why option A is correct. Both atoms have the same number of electrons in their outer shell. No, that's wrong. Why? Because hydrogen will just have 2 electrons in its shell, whereas carbon will have 8 electrons, right? So it's not the same. So option A is right. Which diagram shows the outer shell electrons arrangement in the molecule of methanol? Now let's see the structure of methanol. So C will make 3 bonds with the hydrogen. So if you see, can C is making 3 bonds with the hydrogen, all these three, 1, 2, okay, 1, 2, 1, 2, all is fine, right? So up till CH3, we all are cleared. But if you see over here, C is just making, C is sharing the electrons. But can you see the electron for hydrogen here? No, right? No hydrogen electron is here. So D option has been rejected already. Okay, so now let's reject this one. We are left with A, B, and C. Now let's come to word carbon and oxygen sharing of the electrons. So carbon and oxygen, of course, will share only 1 electron because carbon already have shared 3 electrons with hydrogen. So it has only one option. It can share 1 electron with oxygen. So it will be complete, right? If you see carbon, 1, 2, 3, 4, 5, 6, 7, 8. Yes, so it's complete, right? Its outermost shell is complete now, carbon here. Let's count here. Yes, 8 is complete. Let's count here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's wrong. Carbon just need 8 electrons. Why it is sharing 2 electrons here? That's wrong. So now we are left with A and B, okay? So now we are done up till here. Let's see now for the OH bond. Now H is sharing 1 electron, right? H is right. H is right over here also. So now what's wrong actually? The actual thing that is wrong is for oxygen. If you see for oxygen, oxygen belongs to group 6. So it will only share 2 electrons because it just needs 2 electrons to make it, right? So it is already sharing 1 electron here, 1 electron here, right? So where are the remaining 4? The remaining 4 are not shown here. But if you see, the remaining 4 are shown here. So 1, 2, 3, 4, 5, 6, 7, 8. So oxygen octet, this 8 electrons are also complete in the last shell. So it means A option is correct. I hope this one is clear because here they are not showing the remaining 4 electrons of the oxygen that are not bonding with anyone, that are not making the pairs, right? They have not shown. So that's why option B is wrong and option A is right. Question 21. Which dot and cross diagram show the outer shell electron arrangement in a molecule of carbon dioxide? So you see, they already have now in the exam, they usually give the picture like this. This is from a new paper or after 2019. So let's see. Carbon has to share all its 4 electrons, right? All the 4 electrons. So can you see here? So there should be 2 bonds here and 2 bonds here. So 2 bonds means 4 electrons. So can you see 4 electrons here? 1, 2, 3, 4. Yes, 1, 2, 3, 4. That's right. That's right. Here you can see only 1 bond, right? 2 electrons means 1 bond. So it means this one is wrong. Here you can also see 1 bond. That is also wrong. So now we are only left with A or C. So C already have used all its 4 electrons right here. So C is complete. 1, 2, 3, 4, 5, 6, 7, 8. But if you see for oxygen, oxygen has just 4 electrons. It's not complete. It means that the remaining 4 electrons are not shared because oxygen has total 6 electrons. 2 it is using here. Where are the remaining 4? It's not shown, but here it is shown, right? So that's why option C is correct. So if you count for oxygen, oxygen also have 8 electrons now. 1, 2, 3, 4, 5, 6, 7, 8, right? 1, 2, 3, 4, 5, 6, 7, 8. So of course, each of them, carbon, oxygen, have gained the noble gas electronic configuration. Question number 22. Again, the structure of ethanoic acid is shown. Which diagram show the arrangement of outer shell electrons in a molecule of ethanoic acid? Let's see, carbon is making 3 bonds with the hydrogen. So if you see here, hydrogen should have no electron outside in the shell here. Okay, it has only 1 electron that will be shared here, so it should have no any lone pair or any lone electron in its shell. Can you see here? No. So that's right, this one is also right, but this one is wrong. Can you see 1 electron here and 1 is here? So it means that's wrong. Hydrogen has only 1 electron, so why it's 2? Okay, so option D is rejected. Now let's see option A, B, C. Which one is left? So now we will see the carbon has a single bond, right? It is also showing a single bond because there are only 2 carbon atoms, right? 2 carbon, two electrons, right? So single bond, 2 electrons, single bond, 2 electrons, single bond, all options are right. Now let's see for carbon and oxygen. If you see carbon or oxygen are making double bond. So double bond means 4 electrons are shared. If you see here, how many electrons are shared? 1, 2, 3, 4. 1, 2, that's wrong. So B is rejected. C, 1, 2, 3, 4. Okay, so A and C can be right. Now let's come toward carbon and oxygen sharing of electrons. Only 1 bond, so means 2 electrons should be shared. 1, 2, yes, 1, 2, right. But if you see here now, oxygen, where are the remaining oxygen electrons? Oxygen has total 6 electrons, right? 1 is shared here, 1 is shared here. Where are the remaining 4? They are not shown here, right? They are only shown in this option C. So option C is the right option. Question 23. Which dot and cross diagram show the arrangement of outer shell electrons in a molecule of hydrogen chloride? So hydrogen has 1 electron, right? So it is sharing all its 1 electron here, right? Now let's see for the chlorine. Chlorine has total 7 electrons in its last shell. So if you see how many electron it is showing, 1, 2, 3, 4, 5, 6, and the seventh one is the shared one, right? So now chlorine also have 8 if you count all of them, and hydrogen also have now 2. So option A is right. The other options you don't need to see because they are wrong. Let's see for methanol. So this is the structure of methanol. Which diagram show the arrangement of outer shell electrons in a molecule of methanol? So for methanol, again, we have hydrogen here. So hydrogen should have no electron in its outside, okay? It should have only 1 electron that is shared inside. So inside it has the electron, but outside no. So that's okay, that's okay. This one is rejected because you see, 1 is outside, but 1 is inside. So that's wrong. Hydrogen has only 1 electron. So option A, C, or D can be correct. Now let's come to word carbon. Carbon is making just 1 bond with hydrogen, right? So it means 2 electrons should be shared. 2 electrons, yes, 2 electrons, 2 electrons, 2 electrons. Here also 2 electrons, here also 2 electrons. So everything is right. Now carbon and oxygen bond. It should share 4 bonds. 2 bonds, so it should share 4 electrons. So can you see 4 electrons here? Yes, that's right. 4 electrons, yes, right. Only 2 electrons, that's wrong. So option D is rejected. Now let's come toward A and C. So every pairing is right. The sharing of the electron is right, but in oxygen, again, they have not shown you the remaining electrons that are not making a bond, that are not being shared, okay? Because oxygen belongs to group 6, and group 6 means it should have 6 electrons, but they are only showing 2 here. So now the remaining 4 are here, right? So option C is correct. Question 25. Which covalent molecule contains 2 atoms bonded together by exactly 4 shared electrons? So covalent molecules that will have 2 atoms and they are bonded together exactly by sharing the 4 electrons. What does it mean? It means when nitrogen and nitrogen is making a bond, there are 2 atoms, right? 2 atoms. So it should have at least 4 electrons shared. Oh, sorry, exactly 4 electron shares. But if you see here, how many electrons are shared here? 6. So that's why N2 is rejected, right? It's not sharing 2 electrons. It is not sharing 4 electrons. It is just sharing 6 electrons. That's wrong. C3H8. If you draw the structure same like this for C3H8, you will see all the carbons are sharing one electron with one hydrogen electron. So each bond has only, because this is a, it all has a single bond, right? C3H8 has, it's a propane. So propane has a single bond. So in single bond, it will always share two electrons. Each atom will be sharing two electrons, right? In single bond. This is also having a single bond. All of them have single bonds. So only two electrons are shared. But here, if you see CH3COOH, so one carbon is actually making a double bond with oxygen. So here it can share four electrons, right? So two from here and two from carbon. So total four. So only in the D we can find. So you have to draw the structure like this, then it will be more clear to you. So you can see that only CH3COOH has the double bond. And because of this double bond now, double bond means sharing four electrons. So option D is right. Sorry, option D is right, okay? This one is not right. I did a mistake over here. Option D is correct, okay? Okay, let's see question number 26. The molecule N2C2H4, carbon dioxide and CH3OH all have covalent bonds. These bonds consist of shared pair of electrons. Which row gives the total number of shared pair of electrons in the molecule shown here? Now, let's see how many pair of electrons they are sharing. So if you see N2, it makes a triple bond, right? So it means it will share three pair of electrons. That's wrong now here. Let's come towards C2H4. So C2H4, if you see here, how many pair of electrons are shared here? If you see, it's actually C is making, one C is making two bonds with hydrogen, right? And other C is also making two bonds with the hydrogen. So how many actually are shared now here? Total six, okay? So let's see which option was right. Yes, option B is correct. Why? If you see, this is ethene. So ethene will actually make carbon-carbon, we will have a double bond, right? So carbon-carbon, when we'll have a double bonds, you are sharing actually two pair of electrons, right? And then we have four hydrogens. So four hydrogen means four pair of electrons. So four pair plus two is total six. So six is only the right option over here for B. So ethene, this option is correct. Even you can try to make the structure and then you will see that this option is right. Question number 27. The formula of ammonia is NH3. Which statement about a molecule of ammonia is correct? So the bonding in a molecule of ammonia is ionic. That's wrong because nitrogen is a non-metal, hydrogen is also a non-metal. So it's a covalent compound. Option B. The nitrogen atom has a noble gas configuration. The hydrogen atoms do not. That's also wrong because both are sharing the electrons. So of course, they both will get the noble gas configuration. So that option is also wrong. Option C, the nitrogen atom share all of its electrons with the hydrogen atom. Again, wrong because nitrogen has total 5 electrons in its last shell, right? But it needs only 3 electrons to complete its outermost shell. So it will just share 3 electrons. Now, option D, there are 6 shared electrons in a molecule of ammonia. Yes, that's right. Because if you see the nitrogen is making, I already told you, whenever you see a covalent compound and it has only a single bond in it. So you see if there are three single bonds, right? And how many atoms now we have here? 4. So 4 minus 1 is equal to 3, right? So 4 atoms will always make 3 bonds. So 3 bonds. So 3 bonds means total how many electrons are shared? Total 6 because each bond is sharing 2 electrons. So option D is right. Question 28. Which row identifies compounds that contain single covalent bonds only, double covalent bonds only, or both single and double covalent bonds? So which row identifies the compound that contains single covalent bonds only, double covalent bonds, or both single and double? Okay, so now let's see one by one. Single covalent bonds only. So C2H4. It's ethene. Ethene belongs to group alkene, right? And the organic compound. So it will always have a double bond. A is rejected. CH3OH, yes, that's right. And carbon dioxide is also rejected because it also have double bonds, right? So B or C can be right. Now let's see double covalent bonds only. So there should be only double covalent bond. Carbon C2H4, we have to check that C2H4, if you see, it is making a double bond between carbon and carbon, but it is also making a single bond with the hydrogen, because hydrogen just need one electron, so it will make a single bond, right? So this option is wrong. Now we are just left with carbon dioxide. Of course, carbon is making double bond with one oxygen and also double bond with other oxygen. So it is just making double bonds. So option C is right. This one, C2H4, it is making both single and double covalent bonds. So option C is correct. Question number 29. The diagram shows the structure of three molecules P, Q, and R. Okay. What are P, Q, and R? Let's see. Okay, so now we come towards the giant covalent structure. So you have to remember this tetrahedral structure is usually for the diamond or silicon dioxide. They both have almost same structures. So if you see here, how we can differentiate that which one is diamond and which one is silicon dioxide, because they both have same structure. You can see it from the atoms. How many atoms are here? How many types of atoms actually are here? Two types. You see, one is black, one is gray. It is showing that it is made up of two different types of the atoms. But you know that diamond is only made up of carbon. So it means this one is not carbon. This one is not diamond, right? Because it has two different atoms present. So it can be silicon dioxide. So can we see here? Yes, C or D option is right. Let's see now for Q. Q, of course, is diamond because only one type of atoms are used, right? So can you see any diamond? Yes, option C. So now the left one is because it's a hexagonal structure. Remember, this structure is always of graphite. So option C is correct. Question number 30. Graphite and diamond are both forms of the element carbon, right? Which row shows the number of other carbon atoms that each carbon atom is covalently bonded to graphite and diamond. Remember that because if you see this structure, graphite is always making 3 bonds with other carbon atoms and 1 electron is actually mobile. That's why graphite are also very good conductor of electricity. So remember, carbon can make 4 bonds, right? Carbon can maximum make 4 bonds, but in graphite, it don't make 4 bonds. It just make 3 covalent bonds. So 3 option is right. And diamond, of course, it's a non-conductor of electricity. Why? Because it's just making a covalent bond and all the electrons are used. So that's why it is a non-conductor of electricity. So carbon in the diamond, it will always make 4 bonds, okay, with each of the carbon. But graphite, it will only make 3 bonds. That's why option B is right. Okay. Question number 31. The structure of 3 substances are shown again here. You can see over here. Graphite, this is diamond, this is silicon oxide. Which substances are hard and have a high melting point? Okay, high melting point, of course, all of them have a high melting point, but hard, it's only for diamond and silicon oxide, not for the graphite, because the graphite has layers of hexagons and they can slide over each other. That's why graphite is lubricant. We also use them in the pencils, right? So it cannot be hard. So option 2 and 3 are right. Where we can see option 2 and 3, D. So option D is correct. Question 32. Which substance is not a macromolecule? If you see diamond, graphite, silicon oxide, they all are macromolecules, right? They are giant structures. Only sulfur is a simple molecule. So option D is correct. How many silicon atoms are bonded to each oxygen atom in a crystal of silicon oxide? So you don't have to remember anything that how is the structure look like. Just remember silicon belongs to which group? Silicon belongs to 4th group, right? So it needs how many electrons? It needs 4 electrons, right, in its outermost shell. So it means it will make 4 bonds with the oxygen. Each of the oxygen, it will make 4 bonds. So silicon, whenever silicon atoms are bonded to 4 oxygen atoms. Is that point clear to everyone? How many silicon atoms are bonded to each? Okay, so here the question is different. They ask you that how many silicon atoms are bonded to each oxygen atom. Now they are not asking about the silicon. So silicon atoms have 4 oxygen bonded, but oxygen atom here now they are asking that how many silicon atoms are actually bonded to oxygen, right? So oxygen belongs to which group? It belongs to group number 6. So how many electrons it needs? Only 2 electrons. So it means it will make only 2 bonds. So 1 oxygen atom will bond with the 2 silicon atoms. I hope this point is clear. So silicon atoms will be bonded with 4 oxygen atoms, but 1 oxygen atom will be bonded to 2 silicon. Okay. So you have to read the question carefully. Actually, they are asking about now here oxygen actually, that each oxygen has how many silicon atoms bonded? So oxygen, of course, needs just 2 electrons. So it means it will bond with only 2 silicon atoms. So option B is right. If they ask you how many oxygen atoms are bonded to each silicon atom, then option D will be right. That is 4. Okay. Question 34. Which row about the properties of both diamond and silicon oxide is correct? They both are the conductor of electricity? No, they are very bad of current. There is no covalent compound or metal, no covalent compound or not covalent molecule that are the conductor of electricity except graphite. Graphite is an exceptional option. Covalent compounds, covalent molecules are bad conductor of electricity. They are very good insulators. Okay, so whenever you see other than graphite, you have to just directly choose an option of no for conductor of electricity. So, of course, no, C and D can be right. Now, what about the type of molecule? Are they giant structures or simple covalent? Of course, they are giant. Diamond is a giant structure. Silicon is also a giant structure. So, which option is right? Option C. Question 35. Which row describes the silicon oxide? Okay. Has a giant structure? Yes. So, A, B, C, all are right. D is rejected. Acidic oxide, of course, it's a non-metal, so mostly it will make an acidic oxide. So now we are just left with A and B because only A and B has the acidic oxide. Now, what about conducting electricity? It does not conduct electricity, right? So option B is correct. How are the structure of diamonds and silicon oxides are similar? Now let's see. They all make the 4 bonds, right? So molecules of both diamond and silicon oxide are held together by weak attractive forces. That's wrong. There is no attractive force between them. There is only a covalent bond, right? So covalent bond and all those 4 electrons are shared. So there is no space for the attractive forces. That's wrong. They both contain atoms arranged in planes held together by weak bonds. Again, weak bonds, that's wrong. They both contain ions that are free to move. Wrong, because it only happens in ionic compounds, but they are covalent, right? The carbon in diamond and the silicon oxide each have 4 covalent bonds. Yes, that's right, okay? So the carbon in the diamond and silicon. Of course, silicon has 4 covalent bonds. Oxygen, not oxygen will make 2, right? So this option is correct, option D. Which row identifies a property and an explanation of the property of for both diamond and silicon oxide? Okay, let's see now. They are very hard, yes. They have high melting point, yes. They are good lubricant, that's wrong. Only graphite is a good lubricant. They are poor conductor, yes, that's right. So we have 3 options, A, B, D. They are right. Okay, now we have to see the explanation. Very hard. Why they are very hard? Because they have giant covalent structure. Diamond has a giant covalent structure and silicon oxide has a giant ionic structure. That's wrong. Both have covalent structure, right? So option A is rejected. Now let's see our option B. Both have giant covalent structure with many strong bonds between the atoms. Yes, between the atoms they have a strong bond, right? Now let's see for D. Both contains only non-metal elements and are simple molecules. No, they are not simple molecules. They are giant structures, right? So only option B is right. Question 38. Diamond and graphite have giant covalent structure of carbon atoms. Which atoms describes graphite? Now, it has a strong, rigid, three-dimensional structure. Wrong. The three-dimensional structure is for the diamond. It has 4 strong covalent bonds between each carbon atom. Wrong. Graphite only make 3 covalent bonds. It's actually diamond that is making 4 covalent bonds between the carbon atoms, okay? See, it has layers which can slide over each other. Yes, that's right. It has layers of hexagon that can slide over each other. That's why it's very lubricant, okay? So option C is correct. It does not conduct electricity. That is also wrong. Graphite can conduct electricity. Which statement describe the attractive forces between the molecules? So you see the attractive forces are always weak. They are actually the intermolecular forces. What does intermolecular forces means? Inter between the molecules, okay? That is called attractive forces. If it is intramolecular, what are intramolecular? Intramolecular means within a molecule. So there are 3 types of intramolecular forces, that is covalent, ionic, and metallic, okay? But this is not intra, this is actually intermolecular. So between the molecules, there will always be weak forces. Now let's see, there are strong covalent bonds. Wrong, because covalent is an intramolecular. There are strong ionic bonds. Wrong. They are weak forces. Yes, this option is right. They are weak forces. Yes, this option is also right. So now let's see which option is more right. They are weak forces formed between covalently bonded molecules. Yes, mostly the attractive forces are between the covalently bonded molecules, not in the ionic compounds. Here they say which holds the ion together. No, the forces that holds the ion together is actually a strong ionic bond, right? So option C is right. Option D is wrong. Question 40. Two statements about silicon oxide are given. It is a hard substance. Yes, okay. It has a macromolecular structure with strong covalent bonds. Which is correct? Both options are actually correct. Okay. So now let's see where we can see this one. Statement is, let's see one by one. Statement 1 is correct, but statement 2, okay, rejected, rejected. Now let's see for these two. So now we are left with A and B. Let's see which. Both statements are correct. Yes, both statements are correct. And statement 2 explains statement 1. But statement 2 does not explain statement 1. So now we will look at statement number 2. That does it explain statement 1, yes or no? So let's see. It has a macromolecular structure with a strong covalent bonds. Yes, it has a macromolecular structure and it has strong covalent bonds. That's why it's very hard. Okay. So option 2 is actually explaining the statement 2 is actually explaining the statement 1. So that's why option A is right. Question 41. Which row describes the properties of silicon oxide? Again, it's a giant structure. Yes, C or D is right now. Let's see the melting point. Yes, it's high. So option C is correct. Which structure does silicon oxide most closely resemble to? Of course, it most closely resembles to diamond. We have the option of diamond. Yes, so it's option B is correct. Question 43. Which substance is a macromolecule? Now see ammonia, carbon dioxide, simple compounds, right? Covalent compounds, water, simple covalent compound. Only diamond is left here, so option C is correct. Diamond is extremely hard and does not conduct electricity. Which statement explain these properties? So let's see now. Diamond is extremely hard and does not conduct electricity. So it has a lattice of positive carbon ions in a sea of electrons. That's wrong. Okay, it is actually sharing the electrons. So we have to see the word where we can see the sharing of electrons. It has delocalized electrons. That's wrong. It has no delocalized electrons. Yes, that's right. It has no delocalized electrons. And each carbon atoms form 4 covalent bonds with other carbon atoms. Yes, that's right. So option C is correct. Why not option D? Because it has strong ionic bonds. Of course not. Diamond is made up of carbon. Carbon is a non-metal. Non-metal can never make the ionic bonds. Ionic bonds are always formed between one metal and another should be a non-metal. So metal and non-metal, whenever combined, they make ionic bond. But only a non-metal? No, it will always be a covalent, okay? Covalent compound or covalent molecule. So option C is right. Question 45. The element silicon has the same structure as diamond. Okay, now they are not asking about silicon silicon dioxide. They are just asking about silicon. Okay, so which statement about silicon is correct? Every silicon atom is bonded to 3 other atoms only. No, because if they have the same structure like diamond, so diamond is making actually 4 bonds, right? So silicon should also make 4 bonds. So that's why option A is wrong. Silicon has a high melting point, yes, because diamond has a high melting point and they have same properties. So that's why we can say that it's a high melting point. Same structure. So same structure will make a same, also have a high melting point. Okay. Silicon is a good conductor of electricity. No, that's wrong. Okay. Why wrong? Because diamond is not a good conductor of electricity. So how can silicon be? Silicon is also a non-metal, right? So silicon has a high melting point. That option is right now. Okay, so option B is correct. Silicon is used as lubricant. Wrong, because diamond is not used as a lubricant. So how can silicon be used if they have the same structure? Okay, so option B is only right. Question number 46. Which diagram represents the structure of silicon oxide? Of course, whenever you see a tetrahedral structure like this, it is actually silicon dioxide, right? So, but two structures are same, right? If you see, both these two structures are same. But now silicon oxide actually have 2 different types of atoms. One is silicon and the other one is oxygen. So you have to see which figure is actually showing 2 different type of atoms. If you see here, all the atoms are shown in a black color, right? So it means it is only made up of single atom. So that is a diamond. But here, if you see, we have 2 different types of the pattern is present here. So it means this one is actually silicon oxide. So option D is right. Question number 47. Which statement about the structure and properties of silicon oxide is not correct? Now we have to see that which properties are not correct. It has a giant structure similar to that of diamond. Yes, right. It has a melting point due to the strong attractive forces between the molecules. Again, attractive forces are never strong, and in between the molecules, of course, never strong, right? So this option can be wrong. Let's see option C. There are strong covalent bonds between silicon and oxygen. Yes, that's right. There are no free electrons, so silicon does not conduct electricity. That's also right. So now I already told you that option B is wrong, okay? Because the high melting point is because of the covalent bond, not because of the strong attractive forces between molecules. There is no extra molecule we have. It's a giant structure. There is no space for the molecules. It's just a structure, a long giant structure in which there is, because all the electrons are used in the bonding, right? All the electrons are used in the bonding for the silicon. So how we can find any attractive forces within that? So we cannot find, and especially attractive forces are never strong. They are always weak. Okay. So that's why it is wrong. The option B is not correct. So that's why it is the best option. Question 48. Which substance have similar structures? Diamond and graphite, diamond and silicon. Of course, diamond and silicon oxide. We don't need to look for other options. So diamond and silicon oxide. B option is right. Two statements about diamond are given. First, diamond has giant three-dimensional covalent structure of carbon atoms. Second, diamond is one of the hardest substance known. So which is correct? Both statements are correct. Yes, both statements are correct. Okay, so A or B can be right. Now let's see, does the statement X1 explain the statement 2? First, statement 1, diamond has a giant three-dimensional covalent structure. Yes, it has a three-dimensional covalent structure. That's why its structure make it is a hardest substance. So statement 1 is actually explaining the statement 2. That's why option A is right. The lead in a pencil is made up of a mixture of graphite and clay. When the percentage of graphite is increased, the pencil slide across the paper more easily. So which statement explains this observation? Graphite has a high melting point. Okay, it has a high melting point, but it has nothing to do with the sliding on the paper, right? If it is sliding on the paper more easily, if we add more graphite, then it means that graphite is actually soft, right? It's lubricant. That's why it's also making the pencil lubricant. So we have to find that option in which it is written soft or lubricant. So can you find any option? Yes, option C is correct. Which statement explain why graphite is used as a lubricant? Again, okay, why it is lubricant? If you see the structure of the graphite, it has an hexagonal structure and it has layers of the hexagons. And these layers can slide over each other. Okay, because if you see, there are weak forces between those layers, and weak molecular forces, they allow them to slide over each other. So option D is right. Layers in the structure can slide over each other. That's why graphite is lubricant. Which substance has the lowest melting point? If you see all of them, you have to find ionic compounds, very high melting and boiling points. Okay, giant covalent structures, high melting and boiling points. Metallic compounds, metallic elements all have the high melting and boiling points. So what is left behind? Only simple covalent compounds or simple covalent molecules. They always have lowest melting point. So graphite, giant covalent structure, rejected. Methanol, yes, methanol is a simple molecule, so it has a lowest melting point. Silicon, giant structure. Sodium chloride, ionic compound. So of course, all of them are rejected. Only option B is right. Which row about the structure and the uses of a diamond and graphite is correct? Okay, which option? Which row about the structure and the uses of diamond and graphite is correct? So now let's see. Diamond structure. Diamond is a giant covalent structure. Yes. Diamond has a simple covalent structure. That's wrong. Graphite has a giant covalent structure. Yes. So option A and C are right. Okay. Now let's see these options and their uses. Giant covalent structure. Diamond is used to make electrodes. How we can use a diamond as an electrode if it is not a good conductor of electricity, right? So that's why it's wrong. Option A is wrong. Only the one that a good conductor of electricity can be used as electrodes. So this option is rejected. Now we are left with only option C. So that's right. Graphite is used as a lubricant. Yes, because the layers can slide over each other. That's why we use graphite as lubricant. So option C is correct. Let's see question number 54. Which statement about graphite explain why it is used as an electrode? Okay, I already told you what things can be used as an electrode. They are the good conductor of electricity, right? So what make them good conductor of electricity? There, can you see an option of it's a good conductor of electricity? No. So now we have to go behind the reason. What makes anything a good conductor of electricity? If it has mobile electrons, or mobile electrons means free electrons, okay? Delocalized electrons that are free moving, or it has ions. Now, graphite is a covalent molecule. Of course, it will have no ions. It's not an ionic compound, right? It has just electrons that are shared. So it means one electron. We already have seen that graphite make 3 bonds, right? Only 3 of the electrons are used in the bonding. So one electron is left. That is actually delocalized or mobile electron that is moving between the layers, okay, hexagon layers, and that movement of the electron between the layers made the graphite as a good conductor of electricity. So that's why it is used as an electron, because it has mobile electrons. So option D is right. I hope this one is clear, because it does not contain ions. So ions and electrons are actually responsible for electricity. But because graphite don't have ions, it just have free electrons. That's why option D is correct. This statement is described as this substance is described as a macromolecule. So usually the word macromolecule, if you see all of them here, sodium chloride, graphite, ammonia, iron. Ammonia, simple molecule, right? But graphite, iron, sodium chloride, they are a giant structure. But usually when you see the word macromolecule and you are confused at which option should I choose, graphite, iron, or sodium chloride now, remember that iron is a metal, okay? So it has a metallic bond. So metallic bond, and for ionic compounds, we don't use mostly the word macromolecule. Macromolecule is usually a word that is used for the covalent compounds or covalent molecules that are giant structures. So graphite is the best option. For this one, sodium chloride, we usually use the word giant lattice structure, okay? For iron, it's a metallic, also giant metallic structure. Graphite is a giant macromolecule or giant covalent structure. So macromolecule and giant covalent structures are same thing. So option B is right. Which statement about carbon is correct? So diamond and graphite both have simple molecular structure. That's wrong. They both are giant structure, right? Diamond and graphite are both used to make cutting tools. Wrong. Only diamond is used because diamond is hard. Graphite is soft. It cannot be used. Each carbon atom in diamond is bonded to 3 other carbon atoms. Wrong. Diamond always make 4 bonds. Graphite conduct electricity and has a giant covalent structure. Yes. Graphite can conduct electricity and it's also a giant covalent structure. So option D is right. Question 57. Which statement describes the properties of both diamond and silicon oxide? Again, we have some properties. Let's see. They are brittle. They are hard. They are malleable. They are soft. Soft, rejected. Malleable, rejected. They are hard. Yes, that's right. They are brittle. Of course not. So B option is right. We don't have to read, but if you want to read, you can also read it with a high melting point. Yes, of course. And are electrical insulators. Yes, they are not good conductor of electricity, right? So option B is right. Question 57. Some properties of the diamonds are shown here, and it is very hard. Every atom form 4 bonds. It does not conduct electricity. So which properties are also shown by silicon oxide? Now let's see. Very hard? Yes. Every atom forms 4 bonds. Okay. Now in silicon oxide, we have silicon and oxygen. Silicon make 4 bonds. Yes, that's right. But oxygen is not making 4 bonds. Oxygen just needs 2 electrons in its outer shell. So it's making only 2 bonds. So option 2 is wrong. It does not conduct electricity. Yes, that's right. So option 1 and 3 is right. Where we can see option 1 and 3? Option C. Okay, so that's why option C is right. So let's see question number 59. Which statement about silicon dioxide is correct? It conducts electricity. Wrong. It is a macromolecule. Yes, that's right. Okay, it's a simple covalent molecule. Wrong. Its structure is similar to graphite. That's also wrong. So only we are left with option B. Okay, so now let's see It's a macromolecule with 4 oxygen atoms bonded to each silicon atom. Yes, that's right, because one silicon atom needs 4 bonds to make, right? To make its to complete its outermost shell electrons. So that's why it is making 4 bonds with the oxygen. That's why option B is right. Okay. Question 60. The structure of diamond and graphite are shown here. Which statement about diamond and graphite is correct? Diamond and graphite contain strong covalent bonds between carbon atoms. Yes, there are strong covalent bonds between carbon atoms. Option A is right. No need to look for the option B, but still if you want to see, we can see diamond and graphite have delocalized electrons. Wrong. Only graphite has. Diamond and graphite have layer structure. Wrong. Only graphite has. Diamond and graphite have low melting point. That's wrong. Both have high melting points. Okay, question 61. Graphite has a giant covalent structure. Which statement about graphite are correct? Let's see now one by one. Carbon atoms form 4 covalent bonds with neighboring atoms. Wrong. In graphite, we can only make 3 bonds. That's why it has one delocalized electron that is helping it to conduct electricity, right? Why it is having one delocalized electron? Because it makes only 3 bonds. Only three electrons are used in the bonding. Now let's see option number 2. There are delocalized electrons between the layers of carbon atoms. Yes, that's right. Graphite is a useful lubricant, right? Graphite is a good conductor of electricity. That's also right. So option 2, 3, 4, all are right. So option C is correct. Question 62. Silicon oxide is a covalently bonded compound. Which statements are correct? Silicon atoms form 4 single bonds in silicon oxide. Silicon atoms forms 4 single bonds in silicon oxide. Yes, because silicon belongs to group 4, so it needs 4 electrons, right? So it will make 4 single bonds. That's right. Oxygen atoms form 2 double bonds in silicon oxide. That's wrong. Oxygen atoms also make 2 bonds, but they are just single bonds, not double bonds. Silicon oxide has a high melting point. Yes, silicon oxide contains 1 silicon atom and 4 oxygen atoms. Yes, that's right, because 1 silicon needs 4 oxygen atoms, right? But if you see, if we have S1 silicon, if you see the formula, it is SiO2. So 1 silicon actually has 2 oxygen atoms, right? So which option is now right? Only we are left with option 1. Okay, silicon atoms, and option 3. That's why option B is only right. Why not 4? Because silicon oxide, if you see the formula of the giant covalent structure, they are not asking about the bond. They are saying that contain. So contain and bonding is different thing. If they say silicon oxide have the bonding of 1 silicon atom with 4 oxygen atom, then it was right. But they are saying that silicon oxide contain 1 silicon atom and 4 oxygen atom. That is wrong, because silicon is actually having, there is 1 silicon and then we have 2 oxygen in the formula SiO2, right? So that's also wrong. So only option 1 and 3 is right. Which statement describes the structure of an ionic compound? Now we will revise all the questions related to ionic compounds. Let's see one by one. It's a giant lattice of oppositely charged ions. Yes, that's right. It's a giant structure and it is a lattice structure and it is made up of oppositely charged ions. So that's why option A is right. No need to look for the other options, but if you want to see, it's a giant lattice of positive ions in a sea of electrons. No, that's wrong. It's actually for the metals. Giant molecule of oppositely charged ions. Giant molecule. No, the word molecule we usually use for the covalent molecules. Okay. Then it is a simple molecule. Of course not. It's not a simple molecule. So option A was right. Which statement about an ionic compound is not correct? It conducts electricity when dissolved in water. Yes, of course, ionic compounds can only conduct electricity when they are melted or they are dissolved in water. When they are solid, they will not conduct electricity. Remember that to conduct electricity, you must have free electrons or free ions. But in a solid structure, in ionic compounds, we don't have free ions, right? So it can only conduct electricity when dissolved in water or actually it is melted. Okay, so now let's see for the second option. It is a high melting point due to strong attractive forces between ions. Yes, it has a strong attractive forces. Okay, between the ions, so that option is also right. It has regular lattice of oppositely charged ions in a sea of electrons. That's wrong. It don't have a sea of electrons. It just have oppositely charged ions. So option C is wrong. Okay. And the ionic bonds are formed between metals and non-metallic elements. That's right. Ionic bonds always form between metal and non-metals. So either you can have two metals and one non-metal, or two non-metals and one metal. It depends. But actually, it is formed only between metals and non-metals. At least you should have one metal and at least you should have one non-metal. Okay. So option C was the right option. Okay, two elements P and Q are in the same period of the periodic table. P and Q react together to form an ionic compound. You can see the structure here. The part of the lattice of this compound is shown here. Which statement is correct? Okay, an ion of P has more electrons than an ion of Q. If you see P is positive. So positive P is actually losing one electron. And if you see this statement, P and Q are in the same period. If they are in the same period, okay, so on the left side, we have metals, right? On the right side, we have non-metals. So if on the left side, we have metals, of course, the metal will have less number of electrons as compared to Q because they are in the same period, right? So of course, the P has less electrons. But here they are saying the ion of the P has more electrons. That's wrong. So A is wrong. Now element P is a non-metallic. You can see it is making a positive ion. How it can be non-metallic? Only metal can make positive ions, right? So B is also wrong. P is to the left of the Q in the periodic table. Yes, that's right. Because metals are usually on the left side of the periodic table, right? On the start of the periodic table, whenever you see your periodic table, the starting of the periodic table is actually your left side. So metals are on the left side and P is actually a metal. It is making a positive ion, right? So C option is correct. The formula of the compound is P4Q4. That's wrong because if they are in the same period of the periodic table, so it depends on the group numbers and they have not mentioned the group numbers here. So we cannot decide that it is P4 or Q4. Okay. So that's why option C is only right. Questions 66. Rubidium is in the group 1 of the periodic table and bromine is in group 7, right? So now they will also make a ionic compound. So okay, rubidium reacts with bromine to form an ionic compound. Which row shows the electron change taking place for rubidium and the correct formula of the rubidium ion? So if you see, rubidium belongs to group 1. What does it mean? It means it's a metal. So it will lose electrons, right? Metal always lose electrons. So let's see. Electron lost where we can see in C and D. So it means C or D option can be correct. Now formula of the ion. Whenever an atom loses an electron, it will gain a positive charge. So rubidium should have a positive charge. So option C is right. Okay. Let's see question number 67. A group 1 elements combine with the group 7 element and forms an ionic bond. Again, which row shows how the electronic structure change? So now group number, what does group number tells you? Group number tells you the outer shell electrons, right? So if in the group 1 element, all those the element should have one electron in its outermost shell before the bonding, right? So which one has one electron in its last shell? A and C, right? So A and C option can be right. Now let's see for after bonding. So after bonding, of course, group 1 elements are metals. They will lose one electron. So now when it lose one electron, this one, what is left? 2,8, right? It should be 2,8. That's wrong. It's 2,8,2. So this one is 2,8. Yes. So option C is right. You don't need to look even for the group 7 elements. But if you want to see, you can see. Now, group 7 actually should have 7 electron in its last shell, right? So it has 7, right? And then when it gains 1 electron, the 7 will become 8. So you see, option C is correct. Question number 68. Magnesium oxide has a high melting point. If you see this one, okay, now we don't know. What is magnesium oxide? It's ionic, it's covalent, it's metallic, what it is. So how you will know? You have to see what is this. Magnesium. Magnesium, if you see in the periodic table, it's on the left side and it belongs to which group? Group number 2. So it's a metal, right? Oxygen is a non-metal. So metal and non-metal always make a ionic compound. So it means magnesium oxide is a ionic compound. Carbon dioxide has a low melting point. So let's see, of course, whenever you see the word low melting point, you will be for sure that it is actually a simple covalent compound, right? But still we can see here carbon, non-metal. Oxygen, non-metal. So non-metal, non-metal always make the covalent compounds or covalent molecules. So one is ionic, one is covalent. So now let's see which row identify the attractive forces that are broken when these compounds are melted. So now you are melting magnesium oxide. Let's see. So which attractive forces is broken here? Remember that in ionic compounds, we don't have weak attractive forces between the molecules, okay? We don't have any force between the molecules in ionic compounds because it's just made up of the ions. There is no molecules in ionic compounds. So if you see the word between molecules, that is wrong. So only this option can be right, C and D. So when you are melting magnesium and oxide, actually the ionic bond, that is a strong force of attraction between ions, is actually broken, okay, almost broken. That's why they are separated. Magnesium will make another ion, positive ions, and oxygen will make negative ions, and they will be separated within the water or maybe when they are melted, okay. So C and D option can be right. Now let's see for carbon dioxide. So when carbon dioxide are melted, what will happen? Because it's a covalent compound, right? So in covalent compounds, always remember what is responsible for that low melting and boiling point. I already told you it's not a covalent bond. It's actually a weak force of attraction between molecules. So you see, they have said that weak attraction between atoms. That's wrong. In between atoms, we have a covalent bond. And covalent bond is not weak. So weak attraction between molecule is the right option. That's why option D is correct. Lithium and fluorine react to form lithium fluoride. A student writes 3 statements about this reaction. Okay, lithium, metal, fluorine, non-metal. So what is this? Of course, an ionic compound. Now let's see. Lithium atom loses an electron when they react. Yes, that's right. Because lithium is a metal, of course, it will lose electron. Each fluoride ion has one more electron than the fluorine atom. Yes, that's right. Because fluoride ion is gaining one electron, more electrons. So fluorine atoms, if it has 7 electrons in the large shell, then fluoride ion will have 8 electrons. So it's one more. That option is also right. Lithium fluoride is a mixture of elements. That's wrong. It's a compound. They both are reacting with each other. It's a chemical reaction. So it should be a compound. It's not a mixture of elements. So 3 is wrong. 1 and 2 is right. So option A is correct. Question number 70. The table contains information about 4 substances. Which substance is potassium chloride? Now, potassium, C, is a metal. Chloride, it's a non-metal. So, potassium chloride is actually a ionic compound. Now, let's see the properties of ionic compounds. They have high melting and boiling points, right? So, can you see 11 very low, 98 low, 772, 1410? So, option C or D can be right, right? So now let's see for option C and D. Can conduct electricity when molten. When it is melted, yes, ionic compounds can conduct electricity when melted or in aqueous solution. They cannot conduct electricity only when they are solid. So when molten, yes. In aqueous, yes. So here we can see the yes, yes, yes here in the option C. So option C is right. Question 71. Chemical compounds formed from a group 1 element and group 7 elements contain ionic bonds. Okay, usually, yeah, that's right, because group 1 metal and group 7 non-metals, whenever they will react, they will form an ionic bond. So now let's see how are the ionic bonds formed. Electrons are transferred. Okay, so yeah, of course, in ionic bonds, electrons are usually transferred from one to another. So who transfer the electrons actually? Who is losing the electrons? Actually, group 1 is losing the electrons, right? So electrons are transferred from group 7. That's wrong. Electrons are actually transferred from group 1. Electrons are shared between group 1. Again, the shared word is wrong. Shared is only used for the covalent compounds, right? Or covalent molecules. Electrons are lost by group 1. That's right. And group 7, but that's wrong. Group 7 don't lose electrons. Now let's see the D option. Electrons are transferred from group 1 atoms to group 7. Yes, that's right. Because group 1 is losing electrons, so it will transfer 8 electrons to the group 7. So option D is right. Question number 72. The arrangement of the electrons in 2 ions formed from elements X and Y are shown here. Okay, so electrons arrangement are shown over here. You can see now. So let's see which equation represent the reaction between element X and Y. So let's see one by one. So we don't know that how many electrons it gain, how many electrons it gain or lose, right? So for that one, we have to look for the proton number. What is the proton number here? It is 19. But if you see here, how many electrons should be here? It should be also 19. But let's count how many electrons it have. 2, then 8, and then 8. So 8 and 8, how many? 16, right? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 8 and 8 is 16, right? So 16 and then you have 17 and 18. Total 18 electrons you have. But P is 19. Protons are 19. What does it mean? It means one electron has been lost already, right? So this one is a positive ion. See here. Electrons are 17. But how many electrons it has? Sorry, the protons are 17. How many electrons it have? 18. So it means one more electron it gained. So X is actually a metal. Y is a non-metal because X lose the electrons and Y gain an electron. And how many electrons it gains? Just one. So it means it belongs to group number 7 because it is gaining one electron. So if it gains one electron and it belongs to group 7, remember that all the elements present in group 7 in nature, they are usually present in the form of diatomic molecule. They are usually present in a form of diatomic molecule. Okay, that's right now. So one X will bind with the other Y because one is losing electron and one is gaining electron. So in ionic compound, the formula will be simple. It has +1 charge, it has -1 charge, right? So the formula will be XY. Let's see where we can find X positive and Y negative. So if you see here, how many, and I already told you that all the group 7 elements actually are in the present in the form of diatomic molecule. Can you see? This is not, this is just an atom, right? It's an atom. But this is diatomic molecule, right? It's a molecule Y2. So option C or D can be right. Now let's come towards what will be the charge. Both are right, yes. Because metals are usually in the form of single atoms, you have to represent them. Metallic bonds are usually represented in the form of their single atom, right? So X is right. You can write 2 to balance it. And now X is losing how many electrons? 1, right? So X should have a positive charge. Which one has a positive charge? Yes, here on C. Y should have a negative charge. Yes. So only one negative charge because it is gaining the electron, right? It is gaining the electron, so the charge should be negative. And now when you balance it, it is 2, Y2, 2, and 2. So C is the right option. Question number 73. The electronic structure of two atoms, P and Q, are shown over here. P and Q combines together to form a compound. What is the type of bonding in the compound and what is the formula of the compound? So now let's see how many electrons we have in the outermost shell. 1, 2, 3, 4, 5, 6, 7. 7. So it's a non-metal, right? It has only one electron. So it's a metal. So metal and non-metal, whenever they react, which compound they will form? Of course, ionic compound. So the bonding will be ionic bond. Can you see an ionic bond? Yes, A and B ionic bond. So now let's see the formula. So formula, because what will be the charge on P? -1 because it just need one electron. Q +1. It just need to lose one electron. So now P -1 and Q +1. What will be now the formula? It will be just PQ, right? PQ. So option A is right because both have just -1 +1 charge. So it's been cancelled. PQ. Question 74. What does magnesium oxide have? Why does magnesium oxide have a very high melting point? So magnesium oxide, because it's an ionic compound. How you know? Because magnesium is a metal, oxygen is a non-metal. So it's have a high melting point. What is the reason behind? There's a very strong double bond between magnesium and oxygen. Wrong. Okay. There is a very strong the double bond is not responsible for that. And also magnesium don't have a double bond with oxygen. Okay. It just have a, you will see, it just have a single bond if you see in the structure. So magnesium is a very strong, okay, there is a very strong attractive forces between the magnesium oxide molecules. What? Molecules. Can you see this word? The molecule word is never used for ionic compounds. So that's also wrong. The oxide ions are strongly attracted to the positive ions. Yes, that's right. Oxide ions are negative, right? And they are strongly attracted toward the positive ions. What are positive ions? Of course, the magnesium ions. So option C is correct. The magnesium ions are strongly attracted to oxide ions, but they have written C of electrons. So that's why option D is also wrong. Question 75. The structure of the sodium chloride can be represented here. You can see, right? One is sodium and one is chloride. What are X and Y? Now you have to see the structure. One is metal ion and the other one is a non-metal ion, right? So let's see. This is metal atom, non-metal atom. That's wrong, right? Because they are not atoms, they are ions. So one is negative ion, the other one is electron. That's also wrong. One is negative ion, the other one is positive ions. Again, wrong. C. One is positive ion and the other one is negative ion. Yes, that's right. One is positive ion and the other one is negative ion. D. Positive ion, yes, but other should be also negative ion. Why? It's electron. So option C is right, okay? That's how you can conclude the answers. Question 76. The group 1 element potassium forms an ionic bond with group 7 element fluorine, right? Which two ions are produced? So group 1, potassium. Of course, potassium belongs to group 1, so it will lose only one electron. It has only one electron in its last shell, so it's going to lose one electron. So what will be the charge? +1. So can you see +1 charge? Yes, it's only on A and B. So now let's see for fluorine. Fluorine belongs to group 7. So how many electrons it needs? It just need one electron to make total 8 electron. That is a stable Nobel gas electronic configuration, right? So that's why fluorine will have a -1 charge. So which option is right? B. Question 77. Metal P reacts with non-metal Q to form a compound. So metal, non-metal, of course, it will be an ionic compound. Which process takes place and which type of compound is formed? So ionic compound is formed, of course. So B or D can be right. Now let's see what happens to the electron transfer. Electrons are transferred from P to Q. Yes, that's right. Because metal is P, so P will transfer its electron to Q. So option B is right. Question 78. Potassium reacts with iodine to form potassium iodide. Which statement about potassium iodide is correct? Potassium, metal, iodine, non-metal. Again, it's a ionic compound. So each potassium atom shares a pair of electrons with an iodine atom. Wrong. Iodine belongs to group 7. Potassium belongs to group 1. So of course they will just share. Oh, well, of course, they will just the potassium will lose one electron and iodine will gain one electron. The share word is wrong. It is only used for the covalent compounds, right? They are not covalent, they are ionic. So share rejected. In potassium iodide, the particles of potassium have more protons than electrons. So in potassium ions, the particle of potassium have more protons then electrons. Yes, that's right. Why potassium have more protons? Because actually potassium is losing electron. The proton number and electron numbers are always equal. But in ionic compounds, potassium, of course, will lose the electron. So when it loses the electron number will be less, right? So that's why option B is right. Potassium iodide has a high melting point. That's also right. But because it's a covalent compound, wrong. It's an ionic compound. Potassium iodide has a low melting point. Of course, that's wrong. Low melting is not a correct option. Magnesium reacts with oxygen to form magnesium oxide. What happens to magnesium atoms and oxygen atoms during this reaction? Now, magnesium and oxygen share two electrons. Again, you see the word share. That's wrong because magnesium, metal, oxygen, non-metal. That's an ionic compound. Ionic compounds never share the electrons. So share, whenever you see the word share for ionic compounds, just reject that option. Magnesium gains 2 electrons and oxygen lose 2 electrons. Wrong. Magnesium is a metal. Of course, it has to lose 2 electrons. Now let's see. Magnesium lose 1 electron and oxygen gains 1 electron. Again, wrong. Magnesium belongs to group 2. If you see in the periodic table, oxygen belongs to group 6. They both need 2 electron to, magnesium needs 2 electron to lose and oxygen gains 2 electrons, right? So that's option D is right. Magnesium loses 2 electrons and oxygen gains 2 electrons. Question number 80. Now again, if you see over here, the diagram shows the part of ionic lattice structure. Which compound does the diagram represent? Okay, so how you will know that which compound is this one? It can be sodium oxide, yes. It can be magnesium chloride. It can be potassium bromide because they all are what? They all are ionic compounds, right? Carbon monoxide, of course, that's wrong. It's a covalent. molecule, a covalent compound. So covalent compound rejected. So A, B, C can be right. Now let's see to the structure. If you see the ion structure, the positive are small and negatives are big, right? The negative, it means the negative ion is a bigger. It means the non-metal has a high, the non-metal atomic number is bigger than that of the atomic number of the metal. So if you see in the periodic table, sodium, potassium and bromine. So if you see in the periodic table, potassium comes before bromine. So it means potassium is smaller, okay, than the bromine. So that's why option A is right. Sodium comes after oxygen. So oxygen atom will be smaller and sodium atom should be bigger. Okay, but here it is the opposite. Actually, the positive one is smaller. So potassium is smaller and bromine is bigger. So option A is right. You can see it in the periodic table. Magnesium oxide is a white solid at room temperature and pressure. Part of the structure of solid magnesium oxide is shown here now. Okay. So if you see magnesium oxide is shown here, magnesium is small and oxygen ions are bigger, right? So now three statements are listed over here. Magnesium ions are smaller than oxide ions because they contain fewer electrons. Second, magnesium oxide has a good electrical conductivity when molten because the ions are mobile. That option is right. Magnesium oxide has a high melting point because of the strong electrostatic attraction between the ions and the delocalized electrons. If you see the word delocalized electrons, what does it mean? It means that's wrong because it is a strong electrostatic attraction between the ions. Okay, not between the electrons. There is no electrons involved, only ions. So option 3 is also wrong. So we are just left with option 2. Option 2 is right, that is D. Why magnesium? If you see magnesium ions are smaller than oxide ions, that's right. But because they contain fewer electrons, that's not the reason. The atomic number of, if you see, of the magnesium is smaller, okay? So that's why magnesium, and if you see magnesium and oxygen, both of them, so magnesium ions are smaller than oxide ions because they contain fewer electrons. That's not the right option. They don't contain the fewer electrons. Actually, it's not because of the fewer electrons. They have the same number of electrons. When magnesium will lose electrons and oxygen will gain electrons. So the number of electrons will be the same. Question number 82. Which statement about ions and ionic bonds is correct? Now let's see. Bromine atoms form negatively charged bromide ions. Yes, whenever bromine will react in ionic bond, in making the ionic bonds, bromine is a non-metal, so it will always make negatively charged ions. So that's right. Option A is correct. But if you want to see other options, you can also see ionic bonds form between elements in group 7 of the periodic table. Wrong. Not only between the elements in group 7. Group 7, when they are making bonds with each other, they are making the covalent bonds, right? Positive ions are formed when atom lose proton. No, when atom lose electron actually. Potassium iodide contains negatively charged potassium ions. Wrong. Potassium is a metal, so it will have positive charge. Okay. Question 83. Which pair of the elements react to form a compound with a strong attraction between oppositely charged ions? Okay, so now let's see which one of them can form a compound with a strong attraction between positively charged ions. What does it mean? It means ionic compound. Positively charged ion means ionic compounds, okay? So now carbon and bromine. Carbon, non-metal. Bromine, non-metal. Of course, no bonding of ionic, and there will be no ionic bond. It will be just covalent. Carbon and nitrogen, of course, not an option because they both are non-metals. Sodium and oxygen. Sodium is a metal. Oxygen is a non-metal. So option C is right. Okay. Sodium and potassium both are metals, of course not. So ionic compounds are formed between metals and non-metals, right? So that's why option C is correct. What happens when sodium atoms combine with chlorine atom to form sodium chloride? Sodium atom each gain one electron. Wrong. Sodium is a metal. It will lose electron. Sodium atom each lose one electron. That's right. And chlorine atom each gain one electron. Yes, option B is correct. Okay. Sodium atom and chlorine atom share. Again, you see the word share here also share, so rejected because it's a ionic compound, right? 85. Which statement describe a property of the potassium iodide? Potassium, metal, iodine, non-metal, ionic compound. Okay, so now let's see the property of an ionic compound. It's insoluble in water. Wrong. 99% of the ionic compounds are soluble in water. Okay, so in general statement, actually the ionic compounds are soluble in water. Wrong. So volatile substance, again wrong. Ionic compounds have a very strong bond, so they are usually solid. All of them are solid at room temperature. So how they can be volatile? Volatile means that can easily evaporate. Okay. Option C. It has a low melting point. Again wrong. It's a giant structure. Very strong bond, so high melting point. It conduct electricity when molten. Yes, that's right. They can conduct electricity when they are melted. Question 86. In which ionic compounds do the metal ions and non-metal ions have the same electronic structure? So now we have to see the one in which the metals and the non-metals ion will have same structure. So you have to look at your periodic table, calcium and oxygen. If you see calcium has 20 and oxygen has 8 atomic number. So even if they lose or gain electrons, 20 and 8 cannot match, right? Let's come toward potassium bromide. Potassium has 19 electrons, bromine 35 electrons, right? They cannot match even if they lose electrons or gain. Magnesium oxide, magnesium has 12 electrons and oxygen has 8 electrons. Yes, it can match because magnesium, when lose 2 electrons, it will have now 10 electrons. Oxygen will gain 2 electrons, so 8 plus 2 is 10. So magnesium oxide option is right, option C. Question 87. Sodium reacts with chlorine to form sodium chloride. Which statement describe what happens to sodium atoms in this reaction? Sodium atoms form positive ions, yes. Sodium atoms form negative ions, wrong. Sodium atoms gain electrons, wrong. Because if it is forming a positive ions, it's actually losing the electrons. So option 1 and 4 are right. It means option B. Which statement about potassium chloride are correct? It conducts electricity when solid because its ions are free to move. That's wrong. Potassium chloride is an ionic compound. Ionic compounds can only conduct electricity when they are melted or in the aqueous state because the ions are not free when they are solid. Option 1 is rejected. It has a high melting point because it has strong intermolecular forces. It has strong intermolecular forces. See this word again. Intermolecular forces word can never be used for ionic compounds because they don't have any molecular forces. Even the ionic compounds are not molecules. They are actually, we don't use the word molecule for them because they just have ions. They are not sharing the electrons, okay? So that's why this option is rejected. Even if they are using the word strong, that's wrong. Where is intermolecular forces? We don't have any intermolecular forces between in an ionic compound. Ionic bond is actually an intramolecular force. Intramolecular force. Okay, remember that. Option 3, sorry. Its structure is a giant lattice of alternating positive and negative ions. Yes, that's right. It's a giant lattice structure made up of positive and negative ions. It's soluble in water. Yes, that's right. So option 3 and 4 is right. And this is option D actually. Okay. Question 89. The table shows some properties of 4 substances. Let's see. 1, 2, 3, 4. And they have high melting point, low melting point. Okay, they are poor or whatever. Which substances are ionic? Now we have to see which of them are ionic, right? So ionic always have high melting points. So option 1, 2, substance 1, 2, and 4 are right. Okay. So up till now, 1, 2, and 4 are right. Electrical conductivity when solid. When they are electrical, so let's see now the electrical conductivity when solid. Of course it's poor. They cannot conduct electricity, right? So 1 is right. This one is also right. 4 wrong. Okay, because it cannot conduct electricity when solid. So now we are just left with 1 and 2. Let's see electrical conductivity when molten. They again say it's poor. No, when they are melted, they are very good conductor of electricity. So good is the right option. So what are we left with? Only option D. 2. Okay, so 2 is only the correct option. Question number 90. Ethanol is a liquid at room temperature and boils at 78 degrees Celsius. Sodium chloride is solid at room temperature. Ethanol made up of carbon and hydrogen. Of course, it's a simple covalent covalent compound. Sodium chloride, ionic compound, right? Which statement about the bonding ethanol and sodium chloride is not correct? Now we have to find the one which is not correct. Each ethanol molecule is held together by weak covalent bonds. No, covalent bonds are not weak. Okay, so that option is wrong. It is wrong, but we can see B, C, D also. The ethanol molecules are held together by weak attractive forces. That's right. They have weak attractive forces in between them. They're molecules, right? The molecules have weak attractive forces. Sodium ions and chloride ions are held together by strong attractive forces. Yes, that's right. The sodium ions, because they did not use the word molecular forces, okay? Strong attractive intermolecular, they did not use the word intermolecular. If you see the intermolecular, that will be wrong. Strong attractive forces. So strong attractive forces means ionic force, ionic bond, okay? The sodium ions and chlorides are held together in a giant lattice structure. Yes, that's also right. So you see only option A is wrong because ethanol molecules are held together by covalent bonds but not weak. Covalent bonds are never weak, okay? So option A is the wrong one. So that's why we have to choose option A. Okay, question 91, information about four substances E, F, G, and H is shown over here. So now what are E, F, G, and H? Now let's see the melting points. Two have very high melting points, right? And two have, okay, three. G has a lower melting point. So now if we see all of them, then graphite, we have options sodium chloride, we have silicon oxide and polyethylene, right? If you see, it's a giant structure. This one is also a giant structure. This one is also a giant structure. So polyethylene, because it's a plastic. So see, wait a minute. So we have to see the option number E. Okay, so E is 1710. So graphite, sodium, or silicon. Anyone else can be right, right? Why right? Because the melting point is very high. If you see, the melting point is very high for E. So it can be a giant structure. So it can be graphite, sodium, or chloride. So C is rejected. Now we are just left with A, B, and C. A, B, and D. Now let's see, does not, okay, now let's see for F. F should also be a giant structure, right? So if you see F is a giant structure, no. Polyethylene, it's not a giant structure, right? So we are just now left with B and D, graphite, right? So now we are just left with D. So G120, it should be, of course, polyethylene. And then if you see H, it's silicon oxide. Of course, it says high boiling point, okay, melting point. But now, because we have concluded that D is the right option, so we also have to see the electrical conductivity one by one. Sodium chloride does not conduct electricity when solid. Yes, that's right. It does not conduct. Graphite conducts when solid. Yes, graphite can conduct electricity when it is solid. 120 does not conduct electricity. Polyethylene, yes, polyethylene does not conduct electricity because it's a organic compound, right? Organic compounds, they are made up, or they are non-metals. They are made up of non-metals, carbon and hydrogen. Of course, they will not conduct electricity. Okay. Good conducts when molten. So silicon oxide can conduct electricity when molten? No, that's not right. So it means this option is also rejected B. We are now left with the D option. Let's see now our D option. Is it right or not? Silicon oxide. E, yes, that's right. It does not conduct electricity when solid. Yes, that's also right. 3500 graphite conducts when solid. Yes, that's right. Polyethylene does not conduct electricity. Yes, that's right. G. Okay. H801 conducts when molten. Sodium chloride can conduct electricity when molten. Yes. So which option is right now? D option is right. Okay. So option D is correct. Yes. Question 92. The bonding structure and melting points of sodium chloride and sulfur dichloride are shown here. Okay. So if you see sodium chloride, metal and non-metal. So it's an ionic compound. Sulfur dichloride, sulfur is a non-metal. Chlorine is also a non-metal. So this one is a covalent compound. This one is ionic compound. So now let's see, why does sulfur dichloride have a lower melting point than sodium chloride? Of course, it's a covalent compound, right? It has a covalent bonding, simple molecular structure, and usually all the simple molecules actually have weak force of attraction between the molecules. That is the reason behind their lower melting point. Now let's see one by one. The covalent bonds in sulfur dichlorides are weaker. Wrong. Covalent bonds are not weaker, okay? So rejected. We don't have to read all. The covalent bonds in sulfur dichloride are weaker. Again, wrong. The attractive forces between the molecules in sulfur dichloride are weaker than the attractive forces between molecules in sodium chloride. So the first was right. But if you see here, attractive forces between molecules in sodium chloride. Sodium chloride is an ionic compound. It don't have the molecules. So rejected. C option is also rejected. The attractive forces between molecules in sulfur dichloride are weaker, right? Then the ionic bonds in sodium chloride. Yes, that's the right option. Option D is correct. You see, they have used actually the word attractive forces between molecules. If the between molecules was not the word, then it was right. But in ionic compounds, we don't use the word molecules. We don't have any forces between molecules because we don't have molecules. We just have ions, right? So option C is that's why wrong. Option D is correct. Question 93. Potassium bromide and methanol are both compounds. Their melting points are different. Which row is correct? So both are compounds. Yes, that's right. But potassium bromide is ionic. Potassium, metal, bromine, non-metal. So metal, non-metal, ionic compound. Methanol, it's only made up of what? Carbon, hydrogen, and oxygen. So it is actually all of them are non-metal. So it is a covalent compound. So which row is correct? Substance with the higher melting points. Methanol or potassium bromide? Which one? Of course, potassium bromide, because it's an ionic compound. So C or D option is right. Now let's see reasons why the melting points are different. The attractive forces between oppositely charged ions is greater than the attractive forces between the molecules. Yes, that's right. Why? Because potassium bromide has the attractive forces that are stronger between the oppositely charged ions, right? And the attractive forces between the molecules are weak. Which attractive forces between molecules? Of course, between the molecules of methanol, right? That's why option C is right. Why option D is not right? The attractive forces between molecules is greater. Which molecules? We don't have molecules in potassium bromide, right? And if you are thinking about methanol don't have a high melting point, okay? So why we are saying that attractive forces between molecules are higher, are greater? So that's why option C is right. Question 94, part of the periodic table is shown over here. Which type of the chemical bond is present in the oxide of F and the oxide of G? So which type of chemical bonding is present? Let's see. Between in the oxide of F and in the oxide of G. So F if make an oxide. F if reacts with oxygen. F is a metal, right? It's on the left side. So whenever F will make an oxide, it will make which bond? Oxygen is actually a non-metal. And this F is actually a metal. So metal, non-metal will always make which oxide? Ionic compound, right? So ionic is the right option. C or D can be right. Now let's see for G. G is a non-metal. So whenever it will make an oxide, it will react with oxygen, right? Oxygen is a non-metal. G is also a non-metal. So which oxide we will get? Of course, a covalent bond will be formed. So it will be covalent. So option C is right. Question 95, the arrangement of particles in each of the two solids, S and T, are shown here. So if you see S, simply a diamond structured tetrahedral. This looks like an ionic compound, right? So what are S and T? So this one is diamond. Of course, it's a diamond. So now let's see which option is right. Silicon oxide, of course, no. Silicon oxide have same structure like S. So T is actually sodium chloride, ionic compound. So option B is correct. Question 96, lithium chloride is an ionic compound and silicon oxide is a covalent compound. So which statement about both compounds is correct? Okay. So one is ionic, other one is silicon. They are not soluble in water. That's wrong, right? Because lithium chloride is soluble. Silicon oxide, okay, may not be soluble, but Ionic compounds are usually soluble in water. They conduct electricity when melted. Wrong. Only ionic compounds can. They do not conduct electricity in solid form. Yes, that's right. Both cannot conduct electricity when they are in the solid form, right? So option C is right. Question 97. Cesium is a metal in group 1 of the periodic table. Which description of the bonding in cesium is correct? So let's see now about the description of the bonding. It belongs to group 1. So what will be the bonding now? Electrostatic attraction between oppositely charged ions. Which oppositely charged ions? One is cesium. Where is another one? They are just talking about the metal. Okay, so metal always make a metallic bond. Now we are talking about metallic bond. So that's why this option is rejected. Electrostatic attraction between positive metal ions, yes, cesium will make a metal ion, and mobile electrons, yes, that's right. So option B is correct, because in metallic bond, how metallic bonds are formed, most all the metals actually lose their outer shell electrons mostly, and these outer shell electrons are just making a sea of electrons around these positive ions, and that's how the metallic bond is formed. Okay, so that's why cesium, because they are just asking about cesium. There is no other non-metal or any other group they are mentioning over here. So it means they are just asking about cesium, a metal. So a metal will always have a metallic bond. The diagram represents the general structure of solid Z. What is Z? Sometimes the students confused between the metallic bond and between the ionic bond, because in metallic bond, when they have the structure like this, they think that, okay, this negative is actually a negative ion, right? But actually it's an electron. How you will know, how you will differentiate? Whenever they are showing the negative ion, it will not be as small as like this electron. You see, it is very small and it is randomly arranged. Can you see these are the electrons are randomly arranged? They are not in a slide structure, right? So when their electrons are randomly arranged and you have positive ions, then it is actually a metallic bond. Remember that, okay? So what is Z? Actually, it is a metal. So now we have to find which one is a metal. Aluminium is the only one that is metal here. So metallic bond. This is actually metallic bond. So A is the right option. Question 99. Four substances P, Q, R, and S are described. P is a diatomic. Okay. Q is a good conductor. Okay, diatomic. Who can be diatomic? Of course, it's a non-metal then. Because it's a diatomic, mostly non-metals form the diatomic molecules. Group 7 or group 5 or group 6 also. So it means P is a non-metal. We already find it. Q is a good conductor of electricity when solid and when molten. So what does it mean? Q only the metals or graphite. Graphite can conduct electricity, okay, when it is solid. But in melted and solid state, both is actually a metal. Metal can conduct electricity even if it is melted or even if it is a solid, okay? Because it has a free electrons or free mobile electrons. So Q is actually a metal now, because they are asking which substance are metals. R is a silver solid with a very high melting point. Of course, ionic compounds, they have very high melting points. Covalent compounds, only giant structures, they have a very high melting point. And then we have metals, they also have a very high melting point. So R can also be a metal. Why can be a metal? Because they are saying silver. So which one? It can be, they are talking maybe about the silver solid, right? The silver, actually the silver Ag. So R can also be a metal. S reacts with oxygen to form a brown gas. That is S whenever react with the oxygen. So this metal is a non-metal, because non-metal whenever react with the oxygen, it will make a brown gas. It will not be a metal, because whenever oxides will be formed, they will not be metal. Oxides are not usually the, you will not get a brown gas. Okay. So that's why the option is Q and R. The option Q and R are right. So we can say that option C is correct. Okay. So S is wrong and P is also wrong. Because brown gas is only formed when nitrogen reacts with oxygen. It's nitrogen oxide. So nitrogen oxide, of course, nitrogen is a non-metal, oxygen is a non-metal. So of course, S is actually nitrogen. So S is also rejected. Question 100. Which row explain the malleability and electrical conductivity of solid metal? Why metals are malleable? Malleable means we can change their shape. So if you can change the shape of anything, why you can change the shape? Because if the layers can slide over each other. Same is for the graphite. You remember the layers can slide over each other. That's why they are very soft, right? They are lubricant. That's why we were using them in the pencil. Same is for the metals. Why metals are malleable? We can change their shape because the metal ions, they are present in the form of layers, and these layers can slide over each other when you apply the force. Okay. So why malleability? Let's see now. The reason behind. Delocalized electrons can move. No, delocalized is not the reason. The positive ions actually this. You see, the row of positive ions can slide over each other. Row of positive ions can slide over each other. So that's why C or D option can be right. Now let's see for electrical conductivity. The reason behind the electrical conductivity of solid metal is that I already have shown you a structure of the metal in the previous questions, that it has electrons, a sea of electrons, right? Because the metal atoms are actually losing their electrons. So electrons are actually responsible for the electrical conductivity in the metal. So can you see electrons? Yes, in option C, we can see delocalized electrons can move freely through the structure. So option C is correct, okay? Which row describes the structure of a solid metal and explains the property? Structure of solid metal. Lattice of negative ions in a sea of electrons. Wrong. If we have metals are actually positive ions, right? So positive, yes, here we have positive ions. Lattice of positive ions in a sea of electrons. So C or D option can be right. Now let's see the property of solid matter. When they have positive ions in a sea of electrons, what will happen? Conduct electricity because the ions are free to move. No, because actually the sea of electrons are free to move. The positive ions usually just slide over each other. They are not free to move. Only the electrons are free to move, okay? The ions just slide over each other. The positive ions just slide over each other. So this option is wrong. Is malleable because the layers of ions can slide over each other. Yes, that's right. The property of solid metal is that they are malleable because the layers can slide over each other. So option D is right. Question 102. Which row contains a description of metallic bonding and property that is explained by reference to metallic bonding? Okay, so let's see now description of metallic bonding. A lattice of negative ions. Wrong. Negative. There is no negative ions. Okay. A lattice of positive ions. Yes, that's right. A lattice of positive ions in a sea of delocalized electrons. A lattice of positive ions in a sea of delocalized electrons. Yes, that's right. Now let's see. A metal will react with an acid. So this property, a lattice of positive ions in a sea of delocalized electrons, how it explained this is explained by this property. Okay, we have to explain this property now. A metal will react with an acid producing hydrogen. So this property has nothing to do with the metallic bonding. Okay, this is not related to the metallic bonding. Of course, the any compound can react with the acid, and if any metallic compound that react with the acid, it will produce hydrogen. That's right. But actually, this is not explained by this statement. Okay, we have to see the exact statement that is explaining this one. Now see, a piece of metal can be molded into different shape. Yes, it has been explained. Why it explains? Because they're already telling you that a lattice of positive ions are there, right? So the positive ions can slide over each other. So that's why the metal can be molded, right? So that's why option D is actually explaining that description of the metallic bonding. So option D is correct. Question 103. Iron is a metal. Its structure consists of giant lattice of positive ions in a sea of electrons. Which statements about solid iron are correct? Now let's see about solid iron. It has a metallic bond. Iron conduct electricity because the electrons are free to move. Yes, that's right. Iron conducts heat because the positive ions are free to move. That's wrong. Iron does not conduct heat because of the positive ions are moving. Okay, because the particles vibrate. It's a solid, the particles will vibrate and they will transfer the heat. Iron has a high melting point due to strong covalent bond. Wrong. Iron has a metallic bond. Iron is malleable because the layers of ions can slide over one another. Yes, iron is a metal. Metals, why metals are malleable? Malleable means they can change their shape when you apply the force because the layers of ions can slide over each other. So 4 is right. 1 is, I think, also right? Because iron conducts, okay, yes. So 1 and 4 means B is right. Question 104. Substance P conduct electricity when solid. Which particles move in solid P so that it can conduct electricity? Okay. Substance P can conduct electricity when solid. So substance P can be a metal or it can be a graphite. There are only two options. We don't have any option that is in solid and it can conduct electricity. So only the metals can conduct electricity when they are solid, or only the graphite when it is solid it can conduct electricity. So who is responsible for conducting the electricity in these solid states? Of course, graphite has delocalized electrons. Metals also have delocalized electrons. So actually electrons are responsible for the conducting electricity. So even if it's a metal, it's a graphite, electron is responsible. Okay, it's not like anions or cations. Anions and cations are only responsible in ionic compounds, right? So option D is correct. 3 only. Which statement about the properties of metal is correct? So which statement about the metals, about the properties of the metal is correct? Metals are malleable because the layers of positive ions can slide over each other. Yes, that's right. Metals are malleable. Okay, so option A is right. If you still want to read other options, I will read for you. Metals conduct electricity when solid because the positive ions move freely through the metal. That is wrong. Okay, positive ions are not responsible for conducting electricity. It's actually the electrons. Okay, and second thing, positive ions are not moving freely in metals. Metals conduct electricity because there is a strong force of attraction between positive ions and delocalized electrons. That has nothing to do with the electrical conductivity. Electrical conductivity we can get the electrical conductivity in any substance if they have delocalized electrons or if they have oppositely charged ions. So oppositely charged ions, we only have free oppositely charged ions. We only have in the ionic compounds when they are melted or in aqueous solution, right? That's why they can conduct electricity. Ionic compounds only when they are aqueous or in the melted form. But metals can conduct electricity because they have delocalized electrons. Okay. So there are only two things that are responsible for conducting the electricity: delocalized electrons or the positive or negative ions, okay, oppositely charged ions. So metals have a high melting point because the positive ions attract each other strongly. That's wrong. Positive ions do not attract each other. Of course, they are positive, both are positive, so they will repel each other. Positive ions and delocalized electrons actually attract each other. Question 106. The diagram show metallic bonding. See, we can see the metallic bonding over here. So you can see small electrons here and also these metal ions. So which labels are correct? So X is actually a positive ions, right? Can you see the positive ion or metal ion? Yes. C or D is right, right? Metal ion or positive ion, both are right. So now let's see about this one. Why is electrons? So they say mobile electron or negative ion. Of course, it's a mobile electrons, right? In metallic bonding, we have mobile electrons. We don't have negative ions. So C option is right. Question 107. Which statement describe metallic bonding? The attraction between a lattice of negative ions and delocalized protons. Wrong. Delocalized electrons. Right? Now the attraction between a lattice of positive ions and delocalized electrons. Yes, option B is right. We have positive ions and delocalized electrons. Question 108. Which statement about metal is correct? Metal conduct electricity, yes, when molten because negative ions are free to move. Again, wrong. Conduct electricity only what is responsible for the delocalized electrons. So that option is rejected. Metal conduct electricity when solid because positive ions are free to move. Again, wrong. Metals and negative ions, we don't have negative ions in metals, right? So option is wrong also. Metals are malleable because the bonds between the atoms are weak. Again, wrong. Metals are malleable because the layers of the ions can slide over each other. Yes, that's right. Option D is right. Why I choose the option B? Sorry, my mistake. Option D is right. 108. Okay, I will correct this one. So option D is actually right because the layers of the ions can slide over each other. So it is actually D, not B. Okay, option D is correct. Which substance exists as a lattice of positive ions in a sea of electrons? Okay, which substance exists as a lattice of positive ions in a sea of electrons? Let's see now one by one. So, which substance exists as a lattice of positive ions in a sea of electrons? Let's see which one. Solid magnesium. If you see solid magnesium, because it's a metal, right? So C option is right. Solid magnesium can only exist as a lattice of positive ions in a sea of electrons. Graphite is of course not, because it's a covalent, a giant covalent structure, liquid potassium chloride, ionic structure, solid silicon oxide, of course it's also a covalent structure giant. So only we have the lattice positive ions in a sea of electrons, means it should be a metallic bond. It should be a metal. So solid magnesium is the right option. Question 110. Which statement explain why metals conduct electricity when solid? Okay. Why metals conduct electricity when solid? For electrical conductivity, they should have free electrons, right, to move. So free electrons. So can you find the electrons? Yes, they have electrons which are free to move. So option B is right. Which statement describes the lattice structure of a metal? The lattice consists of an alternative positive ions, yes, right, but not negative ions. We don't have negative ions, we have electrons, right? So that's wrong. The lattice consists of neutral atoms, wrong. We don't have atoms in it. The lattice consists of positive ions in a sea of electrons, yes. C option is right. Positive ions and sea of electrons. Question 112. Which statement explain why metals are malleable? Malleables, they are soft, we can change their shape. So what is the reason behind it? How we can change their shape? Because the layers can slide over each other. So can you see the layers can slide over each other? Yes, the layers of ions can slide over each other. So option D is correct. Question 130. Which statement about the structure of a metal explain why metals are malleable? Again, the same question. So we have to find where we can see the slides can okay, the layers of metal ions can slide over each other. Again, option B is right. Okay. So the layers of the metal ions can slide over each other. Question 114. Again, you see they are giving the same question again and again, but with different statements. So for the malleability, you just have to find the word, the metal ions can slide over each other, okay? Don't find the word electrons. Electrons are not responsible for the malleability. Actually, the positive ions, when they slide over each other, they make the metals malleable. We can change their shape, okay? So which statement explain why metals are malleable? Because the layers of the positive ions can slide over each other, option D. Metal consists of lattice of positive ions in a sea of electrons. Why is aluminum malleable? You see again. So where we can see its layers of ions can slide over each other. Again, option D is right. Question 116. Copper is a metallic element. Which statement about copper are correct? Now let's see. Copper is malleable because layers of ions are fixed position. Wrong. They can slide over each other, okay? The structure of copper consists of negative ions in a negative. We don't have any negative ions in the metallic bonding. We just have positive ions and electrons, right? So option D, 2 is also wrong. Copper conduct electricity because electrons can move through the metal. Yes, that's right. Electrons hold copper ions together in a lattice of electrostatic attraction. So 3 and 4 both are right. So that's why option D is correct. Which statement about metal is not correct? Metals are malleable, yes, right, because the metals conduct electricity, that's also right. Metal consists of a giant lattice of metal ions, yes, that's also right. Metals have high melting points, so that's also right. Now we have to see the second options. Metals are malleable because the metal ions can slide over one another, that's right. Metals conduct electricity because electrons can move through the lattice, that's also right. Metals consist of giant lattice of metal ions in a sea of electrons. That's also right. Metals have high melting point because of strong attraction between the metal ions. That's shown here. Between the metal ions, how we can have strong attraction? Because metal ions are positive, so positive ions will repel each other. So actually we have strong attraction between the metal ions and the delocalized electrons. So that's why option D is not right. Question 118. Which statement describes the structure of copper? Let's see, copper is a metal, so it has a lattice of negative ions. Wrong. Negative ions, wrong. It has only positive ions. Metals have positive ions only. It has a lattice of positive ions in a sea of electrons. Yes, that's right. It has a lattice of positive ions in a sea of protons. Wrong. Protons, no. Because how we can get the positive ions? When the metal will lose the electrons, right? So that's why option C is right. Question 119. X is a solid at room temperature. X has a high melting point. Solid X can conduct electricity. Okay. So it can be a graphite also, right? Or it can be a metal. Remember that, because which option is telling you that it can be because graphite is solid at room temperature, right? Graphite also have a high melting point. We also know that. And solid X conduct electricity. Of course, graphite can conduct electricity. And it can be a metal, because these all are also the properties of metal. So now let's see if you can see any structure of the metal, or you can find the structure of a graphite. We don't have any structure of graphite here. You remember that graphite has a hexagonal layers, and in between we have weak force of attraction. Okay, so it means there is no graphite structure, but we can find the metal structure here, right? This one is diamond. This one is just simple molecule. This one is an ionic compound, positive and negative ions. And this one, I already told you, whenever you see the big positive ions and very small negative ions like this one randomly arranged, it is actually a metallic structure. That's why option A is right. Question 120. Metals and ionic compounds have similarities and differences in their structure and properties. Which row about metals and ionic compounds is correct? So now we have to see metals, how they are different, okay? Similarity. Both contain positive ions. Yes, metals also contain positive ions. Ionic compounds also contain positive ions, right? A and B both are right. Let's see C and D. Both are malleable. No, only metals are malleable, but ionic compounds are not, right? Now, what is the difference? Only ionic compound contains anions. Yes, anions are negatively charged ions. So in ionic compounds, we have negatively charged ions. But in metals, we don't have positive charge ions, right? So that's why this option is right. But we can see to option B also. Ionic compounds conduct. They have conduct electricity. Maybe they are want to tell using a sea of electrons. Wrong. Ionic compounds conduct electricity only because of the positive and negative ions when they are free, right? So option A is only the right option. Now question 121. Which description of brass is correct? Brass is actually alloy. Alloy means it's a mixture of metals, right? So mixture of metals is actually, we call them alloys. So brass is actually a metal. Question 122. Substance P and Q both conduct electricity, okay? P is a mixture of two different types of atoms, and Q is made only one type of atom. Now, we know which compounds or which elements can conduct electricity. First of all, you need to remember only ionic compounds, metals, and graphite can conduct electricity, right? So metal, they are elements. Because metal, magnesium is an element, right? Metallic bond is present between the element. So only one type of atom is here. Ionic compounds, they are actually compounds. They don't have one type of atoms. They have different type of atoms. So now if you see here, just ignore the P, but if just see Q. Q is made only one type of atom and it can conduct electricity. What does it mean? It means it can be a graphite, right? Or it can be what? It can be an element. So it can be a metal. So what is metal? Metal is also an element, and graphite is also a element, right? So it means Q is an element, right? So can you see Q element? Yes, A or B option can be right. Now let's see. T is a mixture. This, they already have told you it's a mixture. And remember that mixture can never be a compound. It is made up of two different type of atoms, but it is a mixture. What does it mean? It means it is made up of two different type of the metals, and it can be an alloy. So that's why alloy option is right and element option is right. So option A is correct. Okay, I hope you got this point. Question 123. Sodium reacts with chlorine to form sodium chloride. Which row describes the bonding in three substances? In sodium, which bond we have? Sodium is actually a metal, right? So in metals, we have metallic bonds. So can we find any metallic bond? Yes, C or D. It means C or D option is right. Let's see about chlorine. Chlorine is a non-metal. So which bond it will have? Of course, it will have a covalent bond. So which option is right? Yes, covalent bond. Then sodium chloride. Of course, sodium chloride, one is a metal, the other one is non-metal. So it will form an ionic bond. So option C is the correct option.